Audio. Audio. Cool. Sweet, I have audio, so I have to be careful what I say now. This is muted. Yeah. Okay, so where was I? This is not working for some strange reason. I don't know why. I don't know why. It clearly says that the key code is backspace. Let's see, you can check if the key code equals backspace, delete, enter, return, tab. None of them wants to work for me. Option, control, tab. Let's try tab. All caps tab. Alright. Come back here. Refresh. Tab. Ah, that's frustrating. See our console. We're not getting any errors. What the hell's going on here? JavaScript, why are you so weird? Yo, Anna Kim Luke, what's going on? How are you this fine? What day is it? I think it's Wednesday. How are you this fine Wednesday or Thursday, whatever time zone you're in? Why is this not working? Key code. Oh, wait, let me see. If key press, key code. Okay, I'm just gonna do this. Actually, do this entire section. And then I'm just gonna steal this because I know that works for some strange reason. But it doesn't work on the other key. Let's refresh this. And no, what? Am I just doing it? I must be doing something wrong then. Console. Okay. So move rand. This is probably being dice equals random 4. Oh, is that floating points? Can I print this? This might be a floating point. Print dice. I might have to round it. Let's find out. Get a few values. Let's open up our console. Yeah, they're floating points. Okay, so I gotta round these. That's what's going on. That's why it's broken. Alright, let's see. I don't know how to cast this. I think int, I think that's how you do it in JavaScript. I think that's how you do it. Let's find out. Nope. Actually, yes. But I'm not getting any functionality. Something else is broke. And so I can't. Oh, because I'm printing. Okay, right. I need to cast it here. Right. And this should give us exactly what we need. Reload. Sweet. Now we got a random walk. Cool. Perfect. Alright, that's good. That's a good starting point. Yeah, there are floating points. There are returning floating points, but I needed full integers. So we casted the floating points to an integer. I hope that's why you're asking about floating points. Or maybe you're trying to give me a heads up I wasn't paying attention. Cool. Alright, so we have this random walk, and now I'm sure that I can change this back to spacebar. Maybe this will work finally. And I can uncomment this. And then let's go to go. No, what is the spacebar key? What is it? Why is it not easily? I have no idea what the spacebar key is, so let's try enter. I'll accept enter, that's fine. Okay, we'll just do enter then. Sweet. Okay, where am I at with this project? Oh, floating points, got it. Got it. Yo, I cannot pronounce that name. Yeah, and I attempt to do it anyway. 1, 2, 3. What's going on? Good day to you as well. I don't know what that meme is. That face meme. But yeah, I'm gonna try and so a lot of people request that I live stream code and whatnot. And oh, where did my walker go? I need to fix that. So I need to add these. all of them. Well, shucks, I have to check for all of them, don't I? Yeah. Remove ran. So if so, first of all, let's do a first check. If check move left and check move down and check move. I hate that you can't do this in JavaScript. That's annoying. Check move right, and then finally check move. What is it? Check move up. So check if we can move in all those directions. Oh wait, that's not important. Shit, that's not important. Shit. Okay. So we need to check for this, which is 0 is left. So check move left here, and then 1 is going to be right. So I'm going to check move right here, and this is going to be check move. I don't know, up or down. Let's see, mine it should be up. Pretty sure. Makes the most sense. And then this should be down. Why is it overwriting? Okay. And check move. What is this? Oh, down, right? Down. Alright, so now he should not go off screen for run and walk. Yeah, there we go. Sweet. Perfect. I'll be here all day trying to check all directions, but I have faith. I have faith. Okay, cool. So we have random walk. Where am I at? The idea is I want to inject a neural network into this because I have to demonstrate. I have a talk that I have to give at ITP in New York City coming up in a couple weeks, and this is going to be the demo that I'm going to talk about. It's going to be simply this. I'm controlling it currently. This blue circle needs to find the red one, and he will get a score based on how efficient that it can find the red circle. Obviously, I'm going to replace these with sprites later, but that's not important right now. And the neural network is obviously going to be able to play the game a lot better than a human could eventually. And yeah. So, I have to run and walk in. What's next? Let's see. I need to take a quick second. I'll be back. Yeah, I'm using JavaScript because ITP in New York City, they use JavaScript for their school. And if I'm going to give a talk at such a school, I think that it only makes the most sense to write in the language in which their students use. So JavaScript is my favorite, but it's not too far away from C#, and it's actually a pretty simple language once you get like the basic understanding of it. Just for me, I don't really use a lot of the functions and whatnot, so I'm going to have to refer to a lot of Google and Stack Overflow and whatnot, but that's why I'm using Java. And also you can run it in the browser, which is super cool as well. So yeah, still not done. I'll be back. Test, test. Sweet. Cool. Alright, let's continue this thing. Where am I at? Okay, so now I have the random walk. Randomly walk. Next, I want to change that random walk to be a prediction. Do I want to do that this early, or do I want to do obstacles? What do I want to do next? Not a scores? Not really important yet. I guess let's just get the neural network set up. Change your career. Currently in SAP consultant. What's SAP consult? SAP. I don't know what SAP consultant is. We'll switch to web development soon. That's awesome. That's super awesome, man. I say that's super awesome. I don't know what a SAP consultant is, but consulting sounds like that could be interesting too, in my opinion. Alright, so I'm gonna get this set up now. Alright, so random walk. So I need to change this to be okay, I know what I need to do. I need to set the inputs. And to do that, this is how we're gonna do it. I guess, okay, before I do that, I guess I'm gonna set up the obstacles. Yeah, let's do that. Let's set up some obstacles. Let's go and set up, let's see, Google has all of this, draw, so in draw function, okay, so then let's do here, wait, was it, I think it's a rect, yeah, rect, and then some, let's do 32 by C size, comma C size, just to get a good idea of where we're headed. Perfect. Now we want to fill that with black with 0. It's perfect. Okay, so that's going to be an obstacle here shortly. Once I code that, then I can expand out. How do I turn this into an object? That's not important at the moment. So, so some ways to go about solving how to check for if there's free space or not. I guess I can literally set up for surrounding squares around the character, and then they just move according to the character, and if they're filled, collide, there's going to have to be a collider. Or okay, another way around collider is if their space equals one of the spaces within an array, but that also will require looping through an array every time. So then I could also remap movement to an array. So what's the most efficient way, most laziest way to go about doing this? I need to check for colliders. Here. Check the left. What does it check left currently do? Check left says if it's right, if it's greater than. Yeah, it seems like the best way to go about doing this is just doing an array check. Some alternative ways, I would index 1, 2, 3, 4 all the way up to I think 32 or 16 or something like that, and then that would be 1, 1 or 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, and then 1, 0, 1, 1, 1, 2, and then 2, 0, 2, 1, 2, 2, so on and so forth. And so your location would be 1, 0, 1, 1, 1, 2, and you'll check for the net. What's left would be what? 1, 1, obviously. Up would be, what is that? Just minus, so it would be minus on the x, and this will be plus on the x. Z minus on the Y plus on the Y. I think that's pretty good solution, because then I can then feed this array to the neural network as inputs pretty seamlessly. Yeah, that's going to take quite a lot of restructuring. Okay, so let's see, just to make sure I fully think about this. So then this will mean like 0, 1, this will be an array of, hold on, let's see. Not related to what you're doing right now, but what's going to be the input of the neural network? Will it be X, Y coordinates, or will you input the state of every block? Yeah, it's going to be the state of every block. And also the coordinates. It's going to be both, because it needs, well, yeah, I guess in order to be able to define every block, you would also need the coordinates. So so this would be like block 0, 0, this would be 0, 1, 0, 2, 0, 3, since we're working in 2 dimensions, 1, 0, 2, 0, 3, 0, 4, 0, all the way to, I think this is 16 or 32, I don't remember. And so I'll have that array, which will be, what, 32 by 32, so that's, let's find out. Actually, I have it in code. I know exactly how big it is. Let's see, 16 by 16. Right, so that's going to be not 256. Where is 256? Yeah, 256. So the input size is going to be 256. Maybe it might be 512. Let's see, because this will, the state of this. Okay, so then I guess we can do state of this will be 0 for empty, and then 1 for player, perhaps 2 for goal, and then 3 for obstacles. Would that work the same? Yeah, that should be fine. That should be fine as inputs. Sweet. I think that's how we're going to do it. That should be fine enough. Or should we one-hot it? Oh, yeah, we should actually one-hot it. That would be actually a better solution. If we pass one-hot vectors for each space. Let me see. Let me think about this. That's why I hate being out of the office, because I don't have my whiteboard to sketch stuff up. But let's see what we can do with this. I need a bigger brush size. Alright, so let's just do this. Jeez, my drawing is beautiful. It is so beautiful. So, right, so then this will be a one-hot itself, but each one of these will be a one-hot, so the world will be consist of empty, empty, obstacle, player, and fuck. This is so hard to draw with this mouse. Empty, and then obstacle, and then player, and then goal. So this is the possible state for every single space on the grid, and so we'll pass this vector in. So what one-hot encoding is, if there's anyone watching this, essentially whatever state that the location is, you'll just pass a 1 through it. So if it's empty, then you'll pass a 1, and the rest will be zeros. Alright? And if it were like an obstacle in that space, you'd do a 1 here, this would be 0. So 0, 1, 0, 0, and then player obviously 0, 0, 1, 0, and then goal obviously 0, 0, 0, 1. And this is a really good way to encode data for a neural network to make good sense of it. Zeros and ones is what computers love, they thrive off of. So this is a very convenient way to train neural networks when you're encoding your data. Especially classification like this. This is a really good way to go doing it. Um, okay, so that means that for all 256 locations, I will need a vector for each. So let's see, so then essentially that means that I will need to go like first node, second node, third, blah 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 blah, and then 256 node. Can I zoom out a bit? Can I zoom out a bit? Here we go. But all of these nodes itself will be another little neural net of 4. That'll be the inner working of each, right? Okay, so then how do we go from the first layer, the inputs, to the hidden layer? Let's see. 1, 2, 3, 4. Here we go. They each, I guess they would each have their own. Each go into, I guess, okay, yeah, we just concatenate. So then really what we're looking at for inputs, geez, this is getting such a simple example. There's already so many. This would be 256 times 4. Excuse me. 256 times 4, 1,000 inputs. I suppose it's better than a convolutional neural net. Let's see what's going on here. So in this case, why is my throat scratchy? What's going on? I'm dying. Let's see. So in this case, for a neural network, it's better to input the 4 bits instead of a more memory efficient 2 bits because there are only 4 possible states. Yeah, I'm not entirely sure what you mean. Yeah, I'm not entirely sure what you mean. I'm not sure how you went from 4 to 2, and I don't quite understand the context of bits. Anyways, we were going to concatenate this. Oh man, this is going to be awesome. And they're each going to be connected to every single node in the hidden layer. What size hidden layer should I do? Let's see, if we're doing 1,000 inputs. I don't know. Maybe like a 500. Should be fine. And output, we really need what? 4? 4? 4. 2 or 4? I can do either or. Well, yeah, let's do 4, because then we'll pass it through a softmax activation function. So let's do 4 for sure for output. And this will be what? 500. We'll try. I don't want to over complicate things. This is what, 1024, right? 1024 input nodes. Let's make sure that's the math. I closed it. How dare I close the calculator? Alright, cool. Very cool. Now, we got this all sorted. I want to first, I like to always first start with the output for whatever reason. So I'm going to do that. I'm going to do that. So let's go to our, what function is it called? It's called move rand. I'm going to call this move guess. And let's change this to move guess. Oh shit. Move guess. the input you have drawn is 4 bits cell, but there are only 4 possible states. You could instead input only 2 bits. I asked if using 4 bits is better for the neural network. Yeah, 4 bits in this case would be a lot better for the neural network to get a better sense of, because um, there is no real, I mean, I guess you could kind of derive some sort of correlation between the states, like player and goal perhaps could be opposite, and you could encode it that way, and maybe empty and object you can correlate it that way, and kind of like concatenate that input. But you know, there's always like a little component of black magic to neural networks that is really hard to make sense of. But uh, from all the research and papers and stuff that I've done, I find that this is the best way to go about training a neural network, especially when you're dealing with large sizes of inputs. It just has a very clear, concrete understanding of the possible states. Um, but at the same time, I don't want to sit here and discourage you. Perhaps you could try to do that sort of research on your own, and maybe come out with a really cool paper in which you disprove that, you know, passing through 4 states is not the most optimal way to go about it. I don't know. This is just what I find is one of the best ways to go about trying to get a computer to understand what your environment is. Where was I? Move depths. Okay, so currently I need to change this to the neural network prediction, but it's currently just a random walk. So let me think from C# to JavaScript. Let's see. So we need to do like a softmax. So I need to write that. Let's see. Whoops. Let's do softmax. So I can get the algorithm. So I don't remember it on top of my head. So softmax equals, and z is the input of j, equals e to j, the sum of k equals 1 e to j times, okay. Okay, so that's going to be, let's see, so 4 is going to be the sum k equals, yes, the code will be public when I finish this project. It'll be up for you to play with and do your worst. Right round. Shit, I haven't done a softmax algorithm in a while. I forget how to read this. Goddamn pseudocode, I tell you. Okay, so activation of z. Z is a vector. Okay, so z is a vector. Cj, z of j equals. Okay, so z of j. So z is a vector. Activation z of j equals e to the power of z, j to the power of zj. Got it? Got it. Okay, so e to the power of zj. Over the sum of all of them, correct? Yes. Yes, okay, cool, sweet. Alright. I need to write this now before I forget. Okay, so, let's see. The problem is that I don't have my predictions yet, so I'm just gonna go with some random values for now. Let's go, wait, hold on. Let me rethink this for a second. I need, what, 4 outputs, right? 4 outputs, what are they? This is gonna be up, this is gonna be down, this is gonna be left, and this is gonna be right. And so once they pass through the neural network, it's gonna give me a vector of it's gonna give me a vector of predictions, but it's not going to be uh, how you say within the range, the domain that I need. So then I need to pass through a softmax to turn into an actual prediction. And so right now, let me just okay. So now I'm just gonna give a random domain of 10. So let's go up guess equals, it doesn't matter, random to 10, and then down guess. I should probably make this an array, shouldn't I? I see. I see. I see. When I did 1, it's because there is no comma. Right, that's what's going on there. But how do I do... I just want to do 4. Is this it? It shouldn't be. No, And we're back. This is expected what? What? Oh, what happened to my bracket? Of course. Of course. Why of course? I should see some not free. I don't see not free. It's all good. I got what I wanted. I got what I wanted. So, where were we? We're changing the move guess function to be a softmax. So we have our guesses here. I don't need you anymore. I don't need you anymore because I know all of your work. And all of you are, I can comment you out. I don't really need you at the moment. So we have our guesses. We need to now pass those through a softmax function. And as we remember, a softmax is written like so. Oh, dang it, I forgot it closed. So we gotta find it again. Softmax. Softmax. So e to the power of zj, which again, z is a vector, and j is just the indice within that vector, and this is going to be a vector of 4. So, in fact, let me just real quick, just for organization purposes, make this a variable. So variable output count, I guess, equals 4. Just so I can use that variable in other places, and if I need to change it for any reason, it'll be super easy to do. Excuse me, I am burping a lot. Okay, alright, so output count, which is 4. Alright, is that. So now I have a vector of 4, vector 4 of 4 different values. So now, I now need to create a new vector, correct? Yes, and then create a new vector based on this vector. So guess, and then I don't know, we're gonna do P for prediction. I don't know. 4. I wonder if I can do I like that 2 times. Let's see if we get an error. Like, see if they give us some sort of like exception or something. F12. No, they are fine with it. That's cool. Or are they? Yeah, they're fine with it. Alright, move along. So now, P of I equals, as the algorithm says, P of I equals G of I. Wait. Yeah, this is so confusing when I'm thinking about this with JavaScript versus C#. I need a function. I need to get, okay, so first I'm going to write that function. Softmax. Okay. And then this needs an input of a vector. And then it'll spit out a vector. So then I'll just do P of I equal, oh wait. Actually I'll move this into here. This will be needed right there. And then from there I can just do P equals softmax of G. I'll be able to do that. Now let's figure out. I don't know. Let's just do that for now. Actually, keep it there. So how do I define this again? I don't think I need to. I just need to put what it is. Let's do vec. I think this is how you do this in JavaScript. Hey, thanks for stopping by, 123. I hope to see you again soon. I'm going to make the stream a lot more exciting in the future, but for now I'm just testing and just seeing what I should improve upon in the future. But thanks for stopping by. Hope to see you again soon. Alright, so then Softmax passes vector in. Right, so then equals, okay. So then what's the algorithm? I equals the same in the indices, so vec I. This needs to be raised to the power of e. Right, so then when you do, I don't know how to do this yet, but pretty much e raised to the power of the vector indice divided by the sum of all of them. Right, I need a separate function. I need a summer. Let's just do function summer. Summation. Let's do summation. And that also can be a vector. JavaScript's so confusing to program in. It's not that bad. It's not that bad. Okay, so then that means I will need to do e to the power of vector indice divided by the summation of which one? Okay, this is a doozy. Alright, never mind. Look at the wrong one. Summation k equals 1 yeah, same thing. So then just g guess or vect, yeah, vect, because that's what's actually what we got. Summation of vect. Alright, so first things first, let me handle this. How do you do e and how do you do e in JavaScript? E in Java JS math.e. Of course. It makes sense. Of course. Wait, so math.e and then power, or wait, I think like this, you would do like math.pow maybe? Yeah. Number x to the power of y. Okay, perfect. Perfect. So, actually it's too far. Perfect. So the power of, okay, so e raised to the power of the vector indice divided by the summation of the vector. Right. Perfect. So now we need to find summation, and that's going to be done by doing, let's see, summation. Let's look at this. Summation is k. K is going to be the total, and then, or capital K is total, and then lowercase k is where you start. We're starting at 0 all the way up to 4. So e, and then vector 0, e vector 1, e vector 2, e vector 3. Right. All the way up to k. Right. And that's okay. Sweet. So to get started, we're going to have our final variable equals 0. Can you just cast it like this in JavaScript? Will that give me errors? Probably. Let's just do this for now. Final equals 0. 1 second. Final equal, oops, final equals 0. Then we need to add to final. So it'd probably be easier if I turn this to a function. Well, it is a function in itself, so there's no real need. So fine. Well, I guess I need a for loop first and foremost. What is length? Length's gonna be output count, and then final plus equals. Come on, come on. Yep, I think this is exactly what it is. Let's see. Yep. Yep. It should give us the results that we're looking for. Oh, wait. I need to return this. I forgot how do you do that. I guess I have to cast that. Is that really how you do it? Do I really have to cast that as a global variable? I can't return a function as an integer. There has to be a way I can return a function as an integer. JS return function as integer. See what we got here. Return. Oh, is that easy? Ah, I knew that. So then let's do that. We'll just do return final. Right out. Right out. So summation. Boom, boom. And then once do that, then we can return P. Let's rename this for this function. Let's name this shit. Let's name this capital Vec, I guess. Vec. And so we can initialize it here. Vec equals empty array. And then for loop for the outcomes, Vec I equals Softmax algorithm. And then return it. Summation 0, and then add to that, and then return it. Alright, return it back. Okay, so then softmax, where we at? So then P, which we didn't initialize, and I don't think that's important. I don't think that's important. We'll find out. It'll scream at us if it's important. Equals that, and then I want to print P. Yeah, let's just try print P. Let's see how far we get here. Move yes. All right, let's just see what happens. Let's just see what happens. All right, looks like it broke. No, it returned an array. Oh my God, we did it first try. Damn. Can we cry? We did it first try. That's awesome. What the hell is this? Proto concat. What the hell is all this? I can't ask for all that. However, there is one thing that we have to do to make sure that it's accurate, that it actually works. So we have to use the example listed. There should be an example. So if we take the input of 1, 2, 3, 4, 4, 1, 2, 3, 4, 1, 2, 3, softmax, that is right. Okay, so when we input this array, this vector, it better give us this, otherwise we did not apply the algorithm right. So let's try it. Where are we at? No, let's just straight up just do this. G equals boom. Right. Okay. So in that case, then gotta do a couple of things. In Softmax, I gotta make sure to change this. Instead of that, let's do vec count. That length, g length, and then here we even need to do vec.length, just to ensure that it stays the same size. And hopefully this doesn't give us any errors. Let's run it. Come on, come on, come on. Oh God, here we go. What is, I think we did it. I think we did it. 0.024. 0.024, when you round that, it is 2.024. 0.064. 0.064, you round it, yep. 0.175. 0.17. Dudes, we did it. First try. We did it first try. 0.475. 0.7. Damn. Celebration. 64175. Celebration. That is awesome. Alright, so we got our Softmax algorithm working to perfection, as you have just seen demonstrated. And I think that is where I'm going to end for today. Actually, no, I want to do one last thing. So this is doing a guess for random. I'm sorry. So it's making a random guess for all 10 spots. And we're going to change this right here to be neural network, to be passed from the neural network to here. This is what GI is going to equal. The guess is going to be the last. I have that diaphragm I can pull up. So these right here are going to be a guess. Boom, boom, boom. Guessed array, and then we're going to have it pass through the Softmax. Damn it. Can I expand this? I can. What am I doing? I'm just expand this out. Get a little more room. Right? So if there's anyone by chance, which I highly doubt there are, that are watching this for educational purposes, this is what G equals. So later, when we write our neural net, it's going to go all 1,024, I think. Yeah, 1,024 inputs are going to be passed through our neural network. Our hidden layer is going to have 500 nodes, and then those 500 nodes do the calculation and pass it through to G. And then that's where G is here. Currently, there is no network to be passed from, so we're doing a random guess. And then once it does that, then it goes to the Softmax algorithm here, which is just a really nice way to get a nice classifier going, and it's going to take a guess on which is the best, most optimal way to go up, down, left, or right. Just in, you know, it turns it into a probability. Yeah, so that's where we're at. Whoops. And last thing I'm gonna do before I get off this stream is I'm going to make it so that it actually moves according to the guess. So we now have P. P is a new vector. That's what we're printing, right? Yeah. P is a new vector that holds the guess. So now we're going to do a for loop. Output count. I guess we can do at this point P dot count length. We do P dot length, and then let me think. I just need to check for the biggest one in the most laziest way possible. The biggest value. I guess we can just do like, let's do a temp equals 0, and then if temp is less than, if temp is less than pi, then temp equals pi. I guess we need a store variable equals -1. so we don't want it to be 0 by default. And if that's the case, then store equals 1. I'm sorry, equals I. Will equal I. And that should get us the index that we'll need for the height. So let's do let's both print P and let's print P store. And this should give us the highest from that array. Where are we at? Hit enter, go into here, and as you can see, it did its guesses, and then it gave us 995 as the highest, which you can see it is. Do it again. You can see it takes a guess, random guesses, and it says that 594 is the highest. You can look and see that it is. And just for redundancy, I'm going to do a couple more times. Boom, boom. And you can see that it says 955 is the highest. Again, looked at all the values, definitely is. 523 is the highest, definitely is. Let's see. Satalis says I really want to be watching the stream, but I'm having issues. Serious issue with the buffering? I'm pretty sure I live in a bad place. Hey man, I'm sorry about that. It definitely it's not Steam. Twitch is telling me on my end that I have excellent bitrate. My stream health is excellent. I apologize about that. I'm sorry that you couldn't tune into the stream. I am gonna upload it though. I'm gonna upload this video, and I guess it's gonna be here on this as well, so you can watch it later if need be. Cool. So this tells us, this right here tells us what direction to go. If we go up, down, left, right, you know, for each of them, this will be a guess of going up. This would be a guess of going, which was it? Up, down, left, right, go right. This would be go up. This would be up, down, left. So let's now just get that in. We don't need this dice roll anymore. We don't need that dice roll. We just need let's see what's the best way to go about doing this. If I guess if P I guess if store, we don't even need, yeah, if store equals 0, yeah, I think this is perfect. KU shit, if store cool. Alright, now let's see what we got. Whoop, whoop, up. Something broke. No, why are you not moving? Store. If store equals right. What the fuck? What is store equal? The hell is store equal? Store equals 1. Store equals 1, 0, 2, 1, 3, 0. What the hell? That's equals this yeah, equals, okay. Answer for 0, but not the other ones. Oh, there we go. This is because the first one. It's so fascinating. Alright, well, here we go. We have our player moving according to our Softmax algorithm, which is perfect because now we can work backwards. If we go to our diaphragm, whatever it's called, this is where we're at. We did this part, This is randomly guessed right here, right here. That's where the values comes from for this layer. And then we pass it through our softmax. This is an F. That's an F. Pass to our softmax, and then it takes a prediction, so it turns like this into a 0, 0, 1, 0 vector, which is its prediction. And yeah. So next time, whenever that is, I'm going to work on the inputs, because you can't really work on the hidden layers without the inputs. So yes, we're going to work on that next. Cool. Alright, I don't know how to end this. I'm just going to say sayonara. And I'm going to click this button. See you later.